Clean code is non-redundant. Clean code is non-redundant. Redundancy in learning is good. Repetition helps us reinforce concepts. But redundancy in code, that's always bad. I'm not talking about intentional redundancy, like the 5 computers on the space shuttle. I'm talking about accidental redundancy, which we see throughout all code bases. We create redundancy in code all the time. In this video, we're talking about redundancy, the hidden cost of doing the same thing in different places, in different ways, or for different reasons. We'll look at how redundancy sneaks into our code, why it's a maintenance nightmare, and how recognizing it can lead to better systems design. We'll even cover how getting rid of redundancy can reveal missing concepts in your software. So if you've ever had the same bug in multiple places, this video is for you. So let's dive in. Hello world, I'm Scott Bernstein and welcome to The Passionate Programmer. In this video, we're diving into redundancy, a subtle but dangerous problem in software development and design. Most developers are familiar with code duplication, copying and pasting the same logic across multiple files. But redundancy goes much deeper than that. There's redundant state, where we have variables that are keeping track of the same thing. There's redundant behavior, where we have methods that do the same thing. There's redundant decisions, where we make the same decision over and over. There's redundancy in algorithms, where we're solving the same problem in slightly different ways. Sometimes redundancy is intentional, like backup systems. But most of the time, it's accidental, and it makes our software harder to maintain, more difficult to test, and nearly impossible to understand. Redundancy is a maintenance issue. You have to fix things in multiple places when something goes wrong. Worse than that, redundancy hides the truth. It prevents seeing the rest of the structure in your system. Removing redundancy often reveals missing design concepts. Every redundant piece of code is an opportunity to simplify our design. The key to spotting redundancy is to do it early, before it spreads through our system. The tricky thing about redundancy is that it's not always obvious. It often hides in slightly different implementations of the same idea. So if we're trying to do the same thing in multiple places, even if we do it in different ways, if our intention is the same, I consider it redundant. Look for copy and pasted code. If you see the same block in multiple places, it's a red flag. Examine your unit tests. If you find yourself writing similar tests for different functions, you may have redundancy in those functions. Oftentimes, I can't see the redundancy in my code, but when I recognize that I'm writing a redundant test, I can spot, oh yeah, there is redundancy in this code, and I can get rid of it. If a single change requires modifying code in multiple places, then it's possible that you have redundancy. Compare 2 function names. If the methods have similar names and similar behaviors, see if you can unite them. Watch for parameter drift. When different methods perform similar work but require slightly different parameters, redundancy might be obscuring a missing concept in your code. Redundancy isn't just an annoyance. It actively slows down development and introduces risk. The real cost of redundancy is oftentimes hidden. It propagates bugs. If a bug exists in one copy, it probably exists in all copies. Minor variations between redundant logic can lead to subtle but hard to find bugs. Large-scale improvements are harder when the same logic is spread everywhere. And here's the worst part. Redundancy hides missing concepts. When we remove redundancy, we often uncover new abstractions that should have been in our design all along. Here's some redundant logic. Both methods almost do the same thing. Apply a discount based on an order total, but they exist separately. So if we need to change the discount logic, we have to do it in 2 places. Here's the after code, after refactoring. We've reduced the redundancy. By pulling out the redundant calculation, we have a single place to update the logic. This makes our code simpler, more maintainable, and less prone to errors. Often, eliminating redundancy reveals something deeper, a missing concept in our design. Here's some signs that you are discovering a new class. The extracted method implies multiple responsibilities. So you extract out a redundant piece of code, and then you see that it has more than that responsibility. It oftentimes indicates it's a missing class. Other parts of the system could benefit from the same logic. This also indicates that this should be its own entity. You find related methods that would naturally belong together, and this is telling you that that missing class is coming together. For example, in our refactored code, calculate discount might belong to a discount calculator class instead of being a loose method. That's how refactoring leads to better designs. These are the 5 key code qualities I call clean: cohesive, loosely coupled, encapsulated, assertive, and non-redundant. These 5 code qualities guide me. They show me what practices are good and what practices I want to avoid. They give me options. They tell me if the options that I'm thinking of will render good code or will create poor code. If you want to write better code, you don't have to memorize a bunch of rules. You just need to understand what makes great code great. And that's why I created the Clean Code mini course, a 5-day email series to teach you how to write more maintainable, scalable, and professional quality code. Each lesson is short, actionable, and packed with real-world examples, so you can improve your code in just a few minutes each day. Want in? You can get it for free as part of my Clean Code Toolkit. Just click on the link in the description. It turns out that the key technical practices of Agile software development are also the key to working with AI. If we know them, we can guide AI to build resilient, changeable, agile code. And if we don't know them, it's going to generate a mess for us. So watch this next series. It will help you become a better software developer and survive the big change that's about to happen. Until then, happy coding.